Hello and welcome to BYJU'S JEE. The JEE Advanced 2019 paper was held just a couple of days back, and we're going to analyze the paper for you and then solve a few interesting questions from chemistry. My name is Ashish, and let's get started right away. So, in paper one, the category-wise split up was like this, as you can see on the screen. It was mostly physical chemistry, 28 marks from there, 20 from inorganic, and few from organic. It was 14 marks from there. Paper two, the balance was more towards organic. Yeah, I mean the imbalance rather was more towards organic. We had 24 marks from organic, 22 from inorganic, and 16 from physical. So overall, I think it was almost equally balanced on all three fronts. Let's look at what happened from 11th and 12th. Yeah, in both the papers. What was the distribution there? So marks from the 12th were fewer from the 11th. Yeah, 35 on the 11th and 27 from the 12th in paper 1. Paper 2 was more or less almost exactly the same. Yeah, 32 from 12th and 30 from 11th. So this is something that students are familiar with as it is, that the JEE mixes things up, but more or less keeps things balanced. Yeah, year-wise and also section-wise. But what is interesting is what we have been doing in the last few years, in the last few sessions, over the last 4 months or so. We've solved most of the types of questions that have actually appeared in this paper. That's very interesting. If you there are 3 questions from atomic structure, and these were pretty straightforward. Yeah, just based on the idea of how Bohr's model worked, and also some ideas from quantum mechanics, where you had to just figure out very simple things, just angular nodes and the number of radial nodes and stuff like that. Equilibrium, a chapter that's usually not tested, or if it is tested, it's usually in tandem with thermodynamics. Now this time there were 2 questions on equilibrium. One where you had some sort of a relationship with kinetics, and another one where you had to form an equilibrium idea with solids involved as well. So very, very basic stuff from physical chemistry. GOC, acidity and isomerism, the usual suspects were also tested. Just one question on polymers, and we've solved a similar question in one of our previous sessions, the polymers and biomolecules session. Yeah, so check that out. Metallurgy. Now, so this was a surprise. Yeah, in inorganic chemistry, there were some questions like the old school of JEE, when the JEE used to be subjective. There was no JEE Main Advanced, just the IIT JEE exam. Now then they would have a scheme of reaction. Yeah, so there were a couple of questions of that sort. And chemical bonding had a lot of questions. There were 3 of them. P block, there were a question on borax again and again. It's been happening every year and happened this year too. We've told you this in our video. And also a question on tin. Coordination chemistry, again, question on isomerism, which we solved. Biomolecules, also one of the questions that has been asked. Again, this is something that's been happening every year. So the reason why I did this in detail is because we've been mentioning these things over the last 3-4 months. I'd pay attention to this because there's a high chance that it would come, and it actually has come in the paper. So that's pretty awesome from chemistry. So anyway, let's get started with some handpicked questions from the JEE Advanced 2019, both paper 1 and paper 2, right away. Here's a question that will have a numerical input as the answer. This is from inorganic chemistry, and the question says, number of N-MnCl bonds, where N-Mn bonds are cis to MnCl bond. In cis Mn whole twice Cl2, how many are these? So that's the question. So what's given to us is that the compound that you want to work with is cis Mn2 Cl twice. This is ethylene diamine. That's what you get. It's a bidentate ligand. Yeah, you need to know this. This is a straightforward question according to me. If you just know what bidentate is and how cis and trans works, that's it. So anyway, you need to find out the N-MnCl bonds, where N-Mn is cis to MnCl. I'll tell you what that means. It's a bit of wordplay. That's all there is. It's quite doable. All right. So the approach obviously is going to be that we have to first draw the structure. We need to know how cis Mn whole twice Cl2 looks like. Without that, this is not possible. I don't think you can do this question without that. So a little bit of practice required there. We'll go ahead and do that. Yeah. So here on the screen right now, you have this in blue. Yeah, this cis Mn2 Cl2. So since it's a bidentate ligand, I've drawn it in this way. Now cis means that these guys are next to each other, and also these are next to each other. So this is the cis form of this isomer. Once you've drawn this out, the rest of it is direct, but there is a small catch here. I'll tell you what I'm talking about. Now, we need to figure out the N-MnCl bond. What is En? I've written that down here. It's NH2, CH2, CH2, NH2. This is a compound En. It's a bidentate ligand. It's basically these you have electrons here, right? Let me count that. I have 5, you have 2, 3, 4, 5. So it's these that act as, the donors. Okay, so now you can see that I've written this down as, I've replaced En with N. Yeah, that's what this is. Because N is the actual atom that bonds. So this is the same as N, another way to represent it. Now I need to figure out cis, Cl, and then bonds. This is what I need to count. So cis, so let me count that. So I have this is 1. I'm going to do a tally over here. And this is 2. And this is 3. Okay? So that's 3 with the first Cl. I'm going to number this as 1 and 2. I'm going to erase this so that this is clear. Now, the reason why I haven't counted this vertical bond is because it's not cis. It goes to the other side of manganese. Yeah, it's in a different plane altogether. So this here is not going to be counted. Yeah, it's trans. So I'm not counting this one. That's the only thing you need to be careful about. You could get a different answer if you counted this, because hey, you need to put the numerical input as the answer, and there's no marks for steps here. You just need to be very, very careful while drawing these. So okay, I've got 3 for the first one. Okay, I'm going to continue counting now. So I have 4 here. That's my tally, and then I have 5 here. Okay, with the scratch, that's 5, and I have this as 6. Again, I do not count this bond here, yeah, which goes from Cl, Mn to N, because it's not cis. So this is where you could have, gotten confused over here. This is the only spot that you need to be careful about. First thing was we drew the structure. We drew the structure correctly. And then the second thing to do was to make sure that you're doing only the cis compounds, which means the cis bonds, which means that you do not count this vertical bond, which is Cl, Mn, Cl, Mn, N, and this bond that goes right across, which is Cl, Mn, and N. So we don't count these 2, and the answer is 6. If you did count them, then it would become 8, which is incorrect. So, yeah, not much to do for a recap here. The main thing you need to know is what is cis trans isomer. Draw the structure. After that, be careful in counting. Answer is 6. Here's a question from organic chemistry that can have more than one correct answer. Now, this is an interesting question. It looks really scary. It's not. It's just a couple of tricks here and there. The main thing is you need to realize the easy parts, and maybe you can also eliminate some options. Anyway, let's get started. Yeah, let me tell you what the question is all about. You can have more than one correct answer. Be careful about that. So you have a benzene ring connected to MEO, there, and then there's a triple bond, and then there's an aldehyde again, which is CHO. Now, first step is you have Ag2 plus reacting with dilute 4. Then this is reacted with AgNO3 NH4OH, and then the famous serine Hg conjugate Cl, which is the Clemens reduction. Yeah, you need to know this. You get Q. Now, from Q, you have SOCl2 and pyridine. Just by looking at this reaction, you may know what's happening. This has to do with forming an acid chloride. Yeah? Anyway, then there's AlCl3, Friedel-Crafts. Identify these ideas when you read the question itself. The last step is R giving that NHESCl to S, which is again Clemens reduction. So just internalizing these steps makes you a lot more confident about solving this question. It does to me anyway. So we look at the question, let's solve it normally, and then let's see if there's maybe a quicker way to do this or something like that. Let's see, let's get started right away. All right, so the first step is this compound I've written right over here, and you have Hg2 plus with dilute H2SO4. Now what happens here is basically this triple bond becomes a ketone group. Now, what this does is that this forms a bit of a complex. This is also a standard reaction. Yeah, it basically breaks down this triple bond, and water attacks this, and you get this. This is a product that you get. You get an enol, and from there, that automarizes and gives you a ketone, which is what is forming right over here. A standard reaction. Let's move on to the next step. Nothing happens to the aldehyde. Yeah, important idea here. So that, when reacted with AgNO3 and then NH4OH, gives you an acid. It only and only affects this group over here, which is the aldehyde, and not the ketone. Yeah, that's the key idea here. This is the mild oxidizing agent. Okay, be careful about this step. A standard reaction from NCERT, but one of the options may test this idea. Yeah, if maybe this gets oxidized to an alcohol or something, doesn't happen. So don't think about that. Oh, not oxidized, that would get reduced, right? All right, so this is not affected. It's just the last, which is this becomes an acid. All right, now from here on, The last step to get Q was this Clemmensen reduction. Standard idea, this keto group goes away and you get this alkane instead. This part becomes CH2, so this is Q. Now from here itself, you can eliminate a couple of options because Q gives you this in one option. We'll look at the options in the end, but let's go through the entire thing, not worry about the question right now. Let's solve this properly. So I have Q. Now from here, this reacts with SOCl2 and pyridine. And right when I saw that, I was like, yeah, okay, I had an idea that maybe there's some sort of an acid chloride being formed. And yeah, sure. So there was an acid and you get this acid chloride right over here. Now from here on, now this is an interesting step. Yeah, you have AlCl3. This is something we've dealt with in our last, we've solved some questions regarding this sort of internal ring formation. Yeah, this Friedel-Crafts is internal. Yeah, it's not addition to an external thing, but this closes the ring over here. So this is the only sort of tricky part, but also kind of obvious if you have solved a lot of organic questions. Yeah, this is the only part where I think students may get stuck, if at all they would. But we'll see this in the end, that if you look at the options, it's kind of obvious that this happens. Yeah, I'll get to that. So anyway, this is the only sort of tricky part that I think, and this is the formation of R. So we got Q and R. One more step to go. You need to get S, the Clemmensen reduction, right? This goes away and you get this over here, which is your product S. I'm going to go back to the options and tell you how to maybe do this quickly. Yeah. So basically, out of these four options, A, B, C, and D, you can see that option A has Q in it and option D has Q in it. You're quite certain that option A is, well, you're sure that option D is incorrect because it has that OH thing on top. And when we figured out, when we were finding out Q, we were quite certain that does not happen. The OH group does not, that group is not there. So you get A could be kind of correct. Okay, that's one thing. Now, if you look at S, yeah, the last product, which I told you was a hint as to why the ring closing definitely happens. The options for S are in B, C, and D, and all of them have a closed ring. Even S has a closed ring. So that one step that I told you was kind of tricky, that almost certainly happens. So you can backtrack this depending on which part of it you're comfortable with. There are like a lot of steps here. Whatever part you're sure about, you can kind of make sure that you are almost certain that A is definitely correct. Okay. And B, you need to get to one step from there. You need to just basically reduce that R, the double bond O, which is Clemmensen reduction, and get that B is correct as well. And there you go. That's the answer. Just A and B are correct. This is a quick way of doing it. We went through the long way of doing it, which is also not that long, to be honest. There are a lot of steps, but most of these steps are common. Yeah, and even the Friedel-Crafts alkylation part was all right because it was an internal idea and that was hinted in the question itself. Answers are options A and B. Here's a question that expects a numerical input as the answer. Now, this question is from the fag end of P block, which is group 18 elements as xenon compounds. It's an interesting question. Let's see what it says. You have XCF4, you start with that. You react that with O2F2 and you get some product. Now, you need to find out the total number of lone pairs of the xenon containing product. So what's the catch here? I mean, it seems like a straightforward question because this is a standard reaction. Are you reacting XCF4 with O2F2? You get some product that's given to us. And you need to basically just find the total number of lone pairs. So when this sort of a reaction happens, what do you expect? You get XCF6 and O2, okay? The thing is, whenever any xenon compound, let's say, whatever it is, yeah, some xenon compound reacts with O2F2, oxygen is relieved, which means that F2 gets added to it. Yeah? If you have XCF2, and it depends on the ratio of O2F2 that you get. You could get from XCF2 to XCF4 and XCF6. Anyway, so here you get XCF6 directly because you start in XCF4. Once you have that, drawing the structure, I think it's one of those standard compounds that you do know the structure to. Even if you haven't done this chapter in detail, you would still know the structure of this if you've done just a bit of chemical bonding. Because it stands out, the structure here is different from what you expect it to be. You see this lone pair, it's in between these other things. Yeah. So because you have here, you have one lone pair and you have 6 bonds. So you expect it to have a weird, like a pyramidal shape, like 5 things over here. something like that, and one on top and one on the bottom. That's what you expect, maybe, but that doesn't happen here. That's why I said there's an exception to the rule. And instead of this sort of a figure, you have this, which is more of a squarish shape with these two, and lone pair being, somewhere in between these over here. So anyway, so this is a structure. Bit of theory that you would be familiar with if you've gone through the ideas of bonding and P-block group-mating elements. Anyway, so let's get to the task at hand. You need to count the number of lone pairs. You say, hey, 1, and that's the answer. But be careful here. The question is not asking you for the number of lone pairs on xenon, Xe. It's asking for the number of lone pairs on the entire compound. Okay? Fluorine also has lone pairs. Be careful about this. So if you were to count, xenon has 8 valence electrons. 6 of these are bonded. Yeah, why? Because I have XeF6. So 6 are bonded, which means that 2 are free. Let's just count the number of electrons and we'll half it again. We'll have it again. That's the easy way to do it. Okay, so this has 2 free electrons on just the xenon. Let's look at fluorine. Fluorine usually has 7 valence electrons. Now, in XeF6, just 1 electron goes away and gets bonded. 6 of them are free on each fluorine atom. And that's the catch over here. So 2 steps as a quick recap as to what has to be done here. You need to know what product is formed, which I think is fairly basic. Yeah. After that, you need to be able to count correctly because it's asking for the number of lone pairs on the entire compound. This is another place where you could mess up if you did not account for fluorine. The last place where I think students could mess up is if you reported the number of electrons and not the lone pairs. So let's get to that, the last part, which is you have 6 free electrons in each. So 6 into 6 is 36. So total number of electrons is 36 plus 2 over here. So that makes it 38. Divided by 2 because you need to get the number of lone pairs, and 19 is the answer right here. So yeah, this one's pretty direct. Here's a question that can have more than one correct answer. This one is from the structure of the atom, atomic structure. Let me read out the question to you. So for He+, the electron is in orbit with energy equal to 3.4 electron volts. The azimuthal quantum number is 2 and magnetic quantum number is 0. So which of the following are correct? The question, it says the subshell is 4D, number of angular nodes is 2, number of radial nodes is 3, and the nuclear charge experienced in n equals 4 is 2e less than that in n equals 1, where E is electronic charge. You're going to deal with the options A, B, C are okay. D looks like you're talking about screening effect and stuff. Scary, right? So yeah, we've given that He+, there's an electron in He+, and the energy is given, L is given, and M value is given. L is equal to quantum number, M is magnetic quantum number. We need to find out basically the subshell it is in, because the 4D idea was there, angular nodes, radial nodes, and also effective nuclear charge. The last part scares me for some reason. Anyway, the approach here is going to be that the energy is going to be proportional to z square by n square. Yeah, you know this already. We'll start with that. And radial nodes is simply n minus L minus 1, and angular nodes is just L. Total nodes from here is n minus 1. Simple, basic stuff. This is if you've done just overall thing of structure of the atom. If you revise it properly. These are basic stuff. So let's look at the first thing. Energy of He+, 3.4 electron volts. Now, but E is equal to 13.6 z square by n square. Something you need to know. There's no way around it. You can't sit and derive this. You have to know this, but this is one of the most basic ideas from Bohr's atomic theory. Yeah, the radius and energy and velocity idea. You must know this. Yeah, this is the most important idea. That and the second part, which is quantum mech, is also tested here. So, interesting question. Anyway, so 13.6 z square by n square should be equal to 3.4 electron volts. Now, Z, as you know, 2, helium, plus, which means that what you get here is 13.6 times 4, which is z squared by n squared equal to 3.4. Now this fraction needs to be 1 by 4. That's what I'm getting at, because 13.6 by 4 gives me this number over here. So how is this fraction going to be 1 by 4 if n square is equal to 16, which means n is equal to 4. All right, fairly basic. I know a little bit lengthy because this is basically 2-3 numericals in all the 4 options, right? If you're looking at a JEE main question, each of these options would be one question by themselves. So anyway, now you know that n is equal to 4. What else? Is there something else? Yeah, the first option talks about maybe this is 4D, this electron in the 4D subshell. Is that true? L value is given to us. L is equal to 2, that means that this is the D subshell. Remember, L is, basically, if I have, it goes from 0, 1, 2, and 3, which is basically the S, P, D, and F subshell. So we're talking about this one here. So this is definitely D, which means that there's a 4D electron. There you go, one option ticked. Yeah, if you're not sure about the rest of the radial nodes, angular nodes, although I think they're quite direct. If you're not sure about that, this is where you cut your loss and say, yeah, I'm done with this. I've spent too much time. Let's move on. But hey, partial marks, you still get them. This one's definitely correct. Option A is correct. All right, radial node is N minus L minus 1. N is 4, L is 2, which means that this is going to be equal to just 1. Not what was in the option. We look at the option. I don't think this was in the options. Angular node is simply equal to L, very L again. That's just 2, right? That's in the question itself. So this is 2. I think this one's correct. We'll look at the options quickly. But first, let's get to that pressing question of effective nuclear charge. What is that about? I'm not sure. It seems like something behind that talks about 2 electrons on. Don't get scared by this. Yeah, there's no way that there's no electron to screen. Forget about the calculation. Yeah, He plus is just a 1 electron system. What is it going to get screened by? There's no screening happening. So this is just to confuse you. This is not even a part of what you should be considering. So if you look at the options, option A is definitely correct. The subshell is 4D. The number of angular nodes is 2. Number of radial nodes is definitely not 3. It's N minus L minus 1, which is 4 minus 2 minus 1, right? That's just 1 radial node. And nuclear charge, yeah, we can ignore that one. It cannot, this doesn't make sense. There's no screening happening, so there's no way there can be 2 electrons less than, because it's just 1 electron there in the first place and there's no screening happening. So this one's not correct. A and B are correct. And those are your answers. Here's a question that has to have a numerical input as the answer. And remember, you need to put it with up to 2 decimal places. Yeah, be careful about that part. All right, so let me read the question out to you. Its mole fraction of urea at 900 grams water is 0.05. Now, density of the solution is 1.2 gram per cc per centimeter cube. You need to find the molarity of the solution. Okay, so what's given to us? We have the mole fraction X urea is what I've written to be equal to 0.05, 900 grams of water. Density is given to us. We need to find molarity. That's what we need. What's the approach going to be like? Well, molarity is simply number of moles of the solute in 1 liter of solution, right? Basic definition. Just write down the definition. You'll be able to solve this question. It's one of those, yeah? Mole fraction of urea is going to be N of, let's take N to be the variable and divided by N plus N of water. These are only 2 things in the solution. Now, the mass of urea then is going to be equal to the number of moles of urea times the molar mass of urea. Yeah, so all the orange things are stuff that we need to find out. That's the point of all these colors. Density now then is going to be just the mass of urea plus mass of water divided by the total volume. You need to find out this volume also because everything else is figured out. Once you have the volume, you divide N by V and you get the molarity. That's it. So yeah, let's get started. This is one of those questions where there are a lot of steps, and it's like solving 2 or 3 JEE main questions one after the other. That's all. So it's just steps. You need to be careful. Just go through things step by step. That's all I would suggest for this question. Let's get started. This is going to be a quick one. So you have X, the mole fraction of urea is going to be given by this equation here. So if I substitute stuff here, and I don't know and everything else is given to me, right? The mass is 900 grams, mass of the molar mass of water clearly is 18 grams per mole. Simple stuff. I'm not explaining that. It's direct. All right. So now N, what is N going to be? If we do this calculation, this is just going to be 50, right? Am I doing that right? Yeah, 50, right? So I have N into 1 minus 0.05 would be equal to, what is this? 50 into 0.05, right? So what I have here is 50 into 0.05 divided by 0.95. Now this is going once, going 19 times. This is 50 by 19. I'm going to keep it like this, although the answer is, what I need to get in the end is in decimal form. That does not mean that every step I get decimal. Yeah, don't do that. You could Well, first of all, it's a risky thing to do because you could make mistakes. And most importantly, you could get a different answer, right? If you take approximations every step of the way, then the last answer would be off by a few decimals. Then you don't know what the JEE would do with that. They could not give you marks for even if you miss out one decimal. I don't know. That could be an issue. More importantly, we want to keep things in fractions so that we don't make errors while doing calculation. We'll do substitution right at the end. I think that's a smart way of doing this. All right. So this is the number of moles of urea. We've got that. Now the number of moles of urea, how do we, the mass of urea is simply going to be the number of moles of urea into the molecular mass of urea. Molecular mass of urea is 60, standard idea. You can calculate this. Once you do that, you get this to be 3000. Right? Yes, 3000 by 90. This is 90. It's simple, 15 to 61. So it's nice that the examiner has given you easy numbers to work with. Yeah, it's good of them. The rest of stuff is fairly direct. I have density is going to be the total mass divided by the total volume. That's what this equation says. Total mass is mass of urea per water. This is given to me. This is something we calculated just now, 3019. Density is also given to me. All I need to just get the volume. Yeah, just take things on the other side. So what I would get is this V is going to be equal to 3000 by 19 plus 900 divided by 1.2, which then I can take 100 out, right? I can take 100 out. So let me take 100 by 1.2 out over here. And once I do that, then I think what I get is 30 plus 9 19. We get right? Divided by you get 201 divided by 19. That's the number that stays there. All right. So just do a simple bit of again. I'm leaving it as it is. Yeah, I'm not doing anything with this. This is the number I got. I'm going to keep it like this. Okay. Now from here, I'm going to substitute on this polarity equation. That's it. I've got the volume. I know the number of moles. And the interesting thing is that 19 just cancels out nicely. Yeah. So it's nice that we did not go ahead and calculate it in decimals. We waited, and that's a good thing in this case. Luckily. So you have 50 by 19 moles, which is the number of moles. Be careful about this substitution. This is the only part you could maybe kind of go wrong in, where you multiply n into b instead of dividing it. I don't see any reason why you would do that. But hey, if you're in a hurry, there's a chance of doing so. So do this slowly. Again, the examiner is being nice. Stuff cancels out. This 19 goes away. And what you're left with is 15 to 1.2, which is 60, right? 60 into 1000 is 60,000. Let me just cancel out these. Life will be a lot easier. So you have 600 divided by 201. So in a normal way of thinking, I would just mark the answer to be 3, right? But hey, you need 2 decimals, so I think this comes out to be something like 2.99. Yeah, so that's the answer. I think even 2.98 would be accepted as the answer. So there you go. That was a numerical. I think it was pretty direct, but you had a couple of steps to it. Yeah. If you're not so comfortable with the concentration terms, it could get a little tricky. But I think it's a direct question, and this is one place where students must get marks. Yeah. It's just a bit of bookkeeping. You need to make sure that all the substitutions have the right units, and most importantly, you don't calculate the decimal value at every step. You keep it in fractions, and stuff cancels out. There you go. Answer this one is right now. Here's a question that requires a numerical input as the answer. It has to be an integer because you're asked to figure out the number of atoms of bromine in the final compound T. Let me go through the question. There's a lot of stuff happening. Could be scary. It's just a little bit lengthy at best. Not scary. One small idea. I'll walk you through it. Anyway, so you have aniline starting with that. This reacts with aqueous bromine, and then reacts with NaHCl, then CuCN and KCN, then H2O and H+, and the last step is SOCl2. The second step definitely has to do with diazotization. Yeah. And the last step, SOCl2, is the formation of an acid chloride. These two you can recognize right away. We'll figure out what happens with the rest. Yeah. It's very doable. Then just benzene, this reacts with oleum, and then NaOH and H2, and then Br2CH2. We go through these. All of these 3 steps are very interesting. And then from R, you react with NaOH first, then again Q, and then you get T, which is the final product. Now this T, you need to find the number of bromine atoms in it. So it's time consuming, yeah, to go through the motions. Unless if you're very good at organic chemistry, maybe you'll do this quickly. But there is a small trick here. Yeah, I'll walk you through the steps. You'll know what it is when it hits you. So aniline, this reacts with aqueous bromine. What you get is a tribrominated product, which I've shown to you over here. Usually, benzene is not very reactive with bromine. But the point is that this, so if you have benzene, to make it react with bromine, you react with FeBr3 and Br2, not just this. You need a catalyst basically. But in this case, we didn't just add bromine. This is because this is being activated. All right. So it makes these three things extremely negative, and the Br plus from here basically attacks. Yeah, this is, I think, kind of standard. So what you'd expect, and you get a tribrominated product. Okay, from here, when you do NaNO2 and HCl, this is the part where I said, you should realize this right away. As soon as you see this, this is the formation of a diazo salt, right? And that's what you get over here. Now this, when reacts with CuCN and HCN, again a standard reaction, it removes the diazo salt, the N2Cl goes away, N2 plus Cl minus goes away, and what you get is CN. Okay, now this, on hydrolysis, you have H2O in presence of acidic medium. What happens is, guess what? It becomes an acid. So the only thing is that this is, you're going across 2-3 chapters. Yeah? You have amine, you have carboxylic acid. So this is what the JEE Advanced does. Yeah, it tests a lot of organic together. You cannot do one chapter and leave the other. That would be very, very risky in organic, which is probably why students find it to be difficult. But stay with me. If you solve this question, just this one question, you will get a lot of hints to the kind of question, the other question also asked in this paper, also maybe in the previous and the ones that come. But that's the beauty about organic chemistry in the JEE Advanced. All right. So the acid that I got, which is a tribrominated acid, this reacts with SOCl2. And this also was a step that I told you was kind of obvious. What happens here is you get a formation of an acid chloride, which is Q. Okay, we're done with the first scheme of reaction. What I want you to note was the first step, because we need to find out the number of bromine atoms. Okay, first step was that a tribrominated product was formed and not a monobrominated, because NH2 group was being activated. Now, here's the, I wouldn't say catch, but here's the interesting thing. Now, whether you have NH2 group or the OH group, both of these are being activated. This is what could be kind of confusing. What am I talking about? Let's see. I start with benzene, and then I have oleum. Oleum is the same as a mixture of H2SO4 and SO3. So here, SO3 basically attacks the benzene ring, and this gets formed in the standard reaction, and that's it. So you get SO3H. Now this, in the presence of NaOH and H2O, gives me phenol. So now we are at the crossroads. Not a direct reaction, but we're at the crossroads now. What happens in this bromination process? Remember, the point is to count the number of bromine atoms. Now, this is where students could make an error. If you pay attention, you won't, but there's a chance of an error here. I have bromine in presence of CS2. This is a non-polar solvent, which means that I don't have enough of these ions, the bromonium ions, which basically form products. So what I get is just a monobrominated that too at this position. So this is the only difference between the first scheme and the second scheme. That in the first scheme, 3 bromine were added right away, and then after that, the steps were kind of doable. And in this, only 1 bromine is added. Now, from here on, the last step, the last scheme, so to speak, is you have this product over here. You have the monobrominated product. You figured out, react that with NaOH, and you get salt. This is the standard idea. You get O minus Na. Now, this, when you react with Q, what happens? What was Q? Remember, it was this compound, the tribrominated product, which we figured out from the first scheme. I'm reacting this with this. Let me write that down again, to explain what happened. So, this is negative, and this is, it has, this is electrophilic. So, you attacks here, you get this product right here. And this is an ester. Although the last couple of steps didn't really change much, the answer that you get is 4. That's it. This is the answer. You needed to be most careful in the first step of the first scheme and the middle steps of the second scheme, where you figure out the number of bromine atoms that were added. That was the only trick here. The first thing, NH2 group was ring activating. That added 3 bromine atoms. And in the second scheme, in the middle, we added CS2, which is a non-polar solvent. So not enough bromonium ions, we have plus ions. So you would get a para product there. And then when both of these combine in this manner in the last scheme, you get this product. And the answer is 4. Here's a question that can have more than one correct answer. This question is on nuclear chemistry. Not tested a lot in the JEE Advanced exam, but hey, it came in the 2019 paper. So that's why we're doing it. You start with uranium in this question and you get to thorium. This is a pK series. There are many different things in the middle. Now you have X1, X2, X3 and X4, which are either particles or radiation that are given off in each step of this series. We need to identify what these particles are primarily. Yeah, so the option says X1 is reflected towards a negatively charged plate. Option B says that X2 is a beta particle. C says that X3 is gamma radiation, and D says that Z is an isotope of U-238. So yeah, what's given to us is fairly straightforward. It's a series itself, and you need to find out X1, X2, X3, and X4 to be able to figure out which of the options is correct. What's our approach going to be? Well, see, I'm saying that you have one of these four particles. Yeah, most likely you have alpha, beta, which are here on the left, and gamma and positron. Yeah, that's what these are. If you don't remember nuclear chemistry, a quick refresher: the thing on top is the mass number, and the thing at the bottom is the nuclear charge. Yeah, so an electron will have that of -1, and a positron has that of 1. Otherwise, the mass is the same for both of these. An alpha particle is a charged alpha particle, doubly charged alpha. Doubly charged helium nucleus is what an alpha particle is. So it has a +2 charge, which is here at the bottom, and a mass of 4. A gamma has no mass. Gamma radiation has no mass and no nuclear charge either. All right. So with this information, let's start the question right away. Now, I very confidently said that these X1 and all of these X's are basically either alpha, beta particles. How did I come to this conclusion? Let's do this step by step. It will be clear to you quite quickly. All right. So I start with U-238. And I get to thorium-234. Now, the main thing that you need to do with any question where some sort of nuclear radiation or particle is given off is you have two equations for sure, which are, first one is the mass balance, which is the top part, balancing on the top. And the second one is nuclear charge balance. Now, this is balancing the bottom thing. Bottom thing is this and the top row. So this means that over here I have X1. Now, from this sort of math, this particle should have a mass of 4 and a nuclear charge of 2. Why? Because that adds up, yeah? If I add up the top parts, 234 plus 4, I get 238. Okay, in this first setup, first series, first step of the series. And at the bottom, the nuclear charge is 92 on the left-hand side. On the right-hand side, it should be 90. And there has to be a 2 on the X1. That's all I need to do. Once I do that, I know that X1 is an alpha particle. Yeah, we just wrote that down. Alpha is basically 4, 2. Beta is -1 and 0. And if you want to write down positron, that's beta and 0. And gamma is just nothing else. It's got no mass and no nuclear charge. So this one's alpha for sure. Now, I can go through the motion, then I'll do that slowly. But you have a trick to figure out that it's only alpha and beta, nothing else. And once you have that, you can actually pretty much solve this question within 30 seconds. We'll do that too. Anyway, so from thorium, X2 is given up. This means that this X2 should have a mass of 0 and should have a nuclear charge of -1. Only then will the nuclear charge gets balanced. On the left-hand side of this setup, thorium has a nuclear charge of 90, but Pa has a nuclear charge of 91, which means to balance it out, there should be a -1. All right, that's why I'm sure that X2 now is a beta particle. With me so far? X3 is interesting. It has the same mass, but I'm not sure about this. Yeah. So X3, Z has the same mass as that of Pa, but X3 therefore should have no mass. I'm not sure about this. This part, the nuclear charge could be either +1 or -1. Now here is where the last step helps me figure out what happens here. The last step, the mass number of X4 basically, this is going to have a mass of 4, right? I'm just balancing that out the top part. So 234 is going to be equal to 230 plus 4. In the bottom part, interesting, I have 90 over here. Now, if there's one catch here, you need to realize that this is one particle or one radiation given off. Yeah, if it's more than that, then things could get complicated. Okay, but at this point, it's just one particle or one radiation that's given off. So if that happens, then this has to be equal to 2. All right, because no other particle has a mass of 4. Okay, be careful about this. So therefore, if I know that this is 2, then that means that this must be, well, this is a little much Okay, let me just draw an arrow and tell you that this is 92. All right. Once you have that, that means that X3 must have a nuclear charge of -1. Only then does the nuclear charge make sense. Yeah, I have 91 on PA, which means that Z plus X3 should also be equal to 91. Now, if Z is 92, then X3 must be 91. Must be -1. So there you go. X3 is beta and last one is alpha. So that's how I figured out that there are only alpha and beta particles. If I just look at the last two steps, it's quite evident that this has to be a beta particle, and with that I should be able to figure out the others also. I could start with that actually. Anyway, we've done most of the hard work. All we have to do now is to figure out what happens in this series. Okay, the options that I had. So X1 is reflected towards a negatively charged is plate. Yeah, sure, it's an alpha particle, right? Positively charged, so it's going to be reflected towards a negatively charged plate. X2 is a beta particle. X3 is gamma. Sure, that one's wrong. So A and B are correct. And D, Z is an isotope of 238U. We have figured this out too, although we did not say so explicitly. Z, we found the nuclear charge of Z to be 92, which is the same as that of uranium. So this is another isotope of uranium, which is U234, right? This is what Z is. This is equivalent to Z. Let me write that down. Yeah, so there you go. So that option is correct as well. So you have the correct answer on your screen. There are 3 of them that are correct. So the JEE is really playing on the fact that you could get away with just knowing a couple of these ideas and mark them and get out of there. Partial marking heavily will affect your score and hence your rank by even hundreds, just by a single mark here and there. So be careful about it. This was a direct question. Yeah, if you just spend maybe around half an hour on this chapter, you would know what alpha and beta particles are. You would know how to do the mass balance and the nuclear charge balance. That's all you needed for this. So the biggest advice I have for you here is do not skip any chapter. Yeah, if you have a year or 2 years to prepare for JEE, read every chapter a little bit, even if it's a little difficult or not so interesting. Just read over it a little bit. It'll really help you out in one way or another. Anyway, so these are the answers. More than one correct answer. Be careful.
For more videos and live lectures on the JEE, click on the subscribe button now.